In this video, we're going to take a look at circuit switching and packet switching technologies and discuss the differences between the two. So, circuit switching, it's been around for a very long time. It was designed in 1878 and originally designed for telephone calls. And I wanted to make sure that I put a visualization in here, so I included this picture, this old picture of a switchboard, a telephony switchboard. I don't know the date for this, but as you can tell, it's very old. Now, the way that this works, the way that circuit switching works, is that it uses a dedicated point-to-point connection, and we'll use this diagram to talk about in a second. So it uses a dedicated point-to-point connection that we call a circuit. So whenever you're trying to communicate with somebody over a telecommunications network, and I made sure I put telecommunications here because while this was originally designed for telephone calls, we also use this for communications with computers as well. So for those of you that have been around for quite some time like myself that used to use something like a 56K dial-up modem, you'll remember that loud, annoying sound when it was connecting and transmitting data over the internet. So we not only use circuit switching for telephones, but we also used it, and we still use it today for telecommunications. And when I say telecommunications, it's a combination of voice, meaning we're using a telephone to communicate with somebody, and also for computers. Now, with a circuit, when we set up this point-to-point communication with a circuit switch, what it does is it guarantees us, you and I, the full bandwidth of the circuit whenever we're using it, and it remains connected for the duration of our call or the duration of our communication. And then when we end our communication or we end our call, that circuit is broken down. So the circuit functions as if the nodes were physically connected with a dedicated circuit. So what in the world does all this mean? Well, we're going to take a look at this, and we're going to talk about this as well as this diagram that I put together. So let's say that I'm over here and this is me, and I want to communicate with the person over here. Well, to communicate, we have to use a phone, or we have to use a dial-up modem, a 56K dial-up modem connected to a computer. And what this does is that when we want to communicate with another person, let's say that this is a switching board area for our local telephone company. And let's say that this is a long distance call or long distance communication. And so it not only has to go through one switching board communication area to another one, but also to another one. And the way that it works is that it'll set up. And for example, a long time ago, these operators here, they had to manually put in these circuits. So if I wanted to communicate with this person over here, they would set up a circuit all the way across from here. And for those of you that remember that long distance calls used to be a lot more expensive than local calls, this is the reason why, because they're physically setting up a dedicated circuit over multiple different telephone companies' switching boards. And when we're using the circuit, nobody else can use it. It's dedicated only for our communication. So we have the full bandwidth. Nobody else can use this circuit. And so this circuit, whenever we're talking to this person, or if we're on our dial-up modem and we're communicating with somebody else, nobody else can use that circuit. And so it's a dedicated electrical circuit set up for our communication. Now that's the way that circuit switching works. Now understand that regardless of how many different telephone companies that this has to traverse, let's say that it's across the entire United States and it's hundreds of different telephone companies, well, when it sets up that dedicated communication, nobody else can use it. Now, conversely, let's take a look at packet switching. So packet switching is how modern networks work, local area networks and wide area networks. Now, when we're talking about frames versus packets, remember frames operate at layer 2 of the OSI model, so when within a LAN, that's with our switches. But with packets, they operate it at the router level, so they operate at OSI level 3. So what this does with packet switching with modern wide area networks, they use what we call our virtual switches. So rather than having a dedicated circuit, we have a virtual circuit that provides a virtual end-to-end connectivity from one device to another, from here to here. So rather than having that one circuit, we use packets, remember when we send data across the network, it's broken up into packets. They have sequence numbers. Once it gets to the other side, they resequence them together and they put the data together. So the packets are sent to the destination. And unlike a circuit sharing or circuit switching technology, packet switching shares the bandwidth in connection with others. And we'll talk about this right now. So let's say that I'm computer 1 over here and I want to communicate with computer 2 across a wide area network. And what I did to depict a wide area network here is we set up multiple different routers. And remember, we use different routing protocols to determine how to route packets of information. So we talked about our internal gateway protocols and external gateway protocols. And depending upon if this is an IGP or an external gateway protocol, meaning we're on the internet, it's going to choose the appropriate protocol. So what these little green dots signify, these signify packets. And so the way that it works is that, well, if we were not on a packet switching, and let me go ahead and change the color of this to green. Let's say we weren't on packet switching and we were on circuit switching. Well, then our communication would only be one path, and we would own that path and utilize that path and have the full bandwidth during that communication. Nobody else could use it. Well, with packet switching, what can occur with all this is that the routers will determine the route. So computer 1 and computer 2, let's say that these are all different packets from this communication from computer 1 to computer 2. Well, let's say that one packet can take this specific route. So let's say that one will go this way, and then it'll go up through here and this way, and then it'll go this way, and so forth to get there. And then another might go a different route. So let's say another one goes in this route. So it goes to here, and maybe it'll just go straight through to this router, and then this router will go down to this one, and then to this one, and then maybe up to this one in here, and so forth. And so the routers will determine the best route as they receive each packet. And so what this allows us to do, it allows us to have this virtual circuit. So from your perspective and my perspective, this just looks like one virtual link between computer 1 and computer 2. But in the background, with all the technology and all the inner workings of the routers, they're determining the best route to send these individual packets. So if there's 100 different packets, they may go multiple different routes. And so what this allows us to do, let's say that we have a computer set up over here on the bottom, and they want to use this wide area network. Well, they can use it as well while we're using it. And maybe there's one up here, or maybe there's one connected right here as well. Again, they can use it as well. And so we have shared bandwidth, and we share this circuit. So that's why we call this a virtual circuit. And this is also the reason why with our modern broadband, so at home, where you'll notice that on certain times of the day and at certain days, maybe on a Friday evening, you notice that your bandwidth isn't as high as it is, let's say, maybe Tuesday at 2 p.m. versus Friday at 8 p.m. Maybe your bandwidth goes down because we're sharing this virtual circuit and we're sharing this bandwidth with others compared to our circuit. And let's go back to this diagram. Compared to our circuit switching, if it's dedicated to us, and this is where when we get into the concept of leased lines, which we'll talk about in a bit in this section, is that it's dedicated to you. You own 100% of the bandwidth. Nobody else can take it. But with this technology, if we have multiple different computers connected up to it, then we have to share the bandwidth with others. And the great thing about this, even though that when there's more people connected, that our bandwidth goes down, with current technologies and internet speeds being the way that they are, we're still going to have adequate bandwidth, and also it lowers our costs. So that's the benefit of packet switching. So that's our introduction to packet switching and circuit switching. Now, what we're going to learn and what you're going to learn specifically in this section is that there are dedicated circuit switching technologies that we'll talk about. There are dedicated packet switching technologies, and there are technologies that use a combination of both. So we're going to go ahead and we're going to start discussing those in our next lectures. So if you have any questions about this, let me know. If not, thanks for watching, and I'll see you guys at the next video.